A simple random sample of 106 healthy adults' body temperatures were taken and found the mean of 98.2 degrees Fahrenheit and a standard deviation of 0.62 degrees Fahrenheit. Construct a 99% confidence interval estimate of the mean body temperature of all healthy humans. We're trying to find the mean body temperature of a population, and we see here that there was a sample of 106 people. The mean of that sample was 98.2, and the standard deviation of that sample was 0.62. Step 1 to creating our confidence interval is to see what we have. Is this from a simple random sample? It is, so we check that off. And then the second thing is our sample size greater than 30. It is. And so we don't have to know if the population is normally distributed or not. The second thing we have to do is we have to determine our critical value. We need to determine, are we using a normal distribution or a t-distribution? Since it gives us the sample standard deviation, not the population's standard deviation, it didn't tell us the standard deviation of all healthy humans. It told us the standard deviation of this random sample. That clues us into the fact that we're going to have to use a t-distribution. Since we're going to have to use a t-distribution, we need to find our degrees of freedom. Our degrees of freedom in this case is 106 minus 1. Therefore, our degrees of freedom is 105. And we also need to know what alpha is. Our alpha is 1 minus our confidence level. So alpha in this case is 0.01. Once we know that information, we're going to have to go to our t-table. And our degrees of freedom is on the left-hand side. It's this left-hand column. And our degrees of freedom was 105. The closest value to 105 is 100. So we're going to be using that row with 100. And then we have to look at area in two tails. Our alpha was 0.01. These are each of our alpha values. So we're going to be using that first column. And we see that the t value is 2.626. Our critical value is 2.626. Now that we have our critical value, we can go on and we can find our E, or our margin of error. Here, our margin of error is going to be the critical value times the standard deviation over the square root of n. 2.626 times 0.62 divided by the square root of 106. So 2.626 times 0.62 divided by the square root of 106. We end up with 0.158137. So E is about 0.158137. Once we do that, we can create our interval. We're going to take our sample mean and subtract our margin of error, and take our sample mean and add our margin of error to get our interval. Our sample mean was 98.20. So I'm going to take 98.20, subtract my margin of error, and I get 98.04. That's going to be less than our population mean, which is less than 98.36, which is the upper value. So therefore, we can say that we are 99% confident that the interval from 98.04 degrees Fahrenheit to 98.36 degrees Fahrenheit actually does contain the true population mean.